Okay, folks, so I'm going to make this brief because I already have a video recorded that I'm going to ask you to look at. But assuming the weather doesn't change, I imagine we'll be at school tomorrow on Tuesday. So that means people in lab wondering what lab we're going to be doing. Had we just had Monday's class instead of it being canceled, I would have gone along with the freezing point depression lab. But because Monday's class was canceled, it would totally get one whole section off schedule. So instead, we are going to go ahead with the Practicum 1 test on Tuesday. If any of you from the Monday section can make it to the Tuesday section, I will try to fit you in with the Practicum 1 test. However, if for whatever reason you cannot make it because of you already have another lab scheduled, we'll try to make it up during the lab next week. Next week, we will do the freezing point depression lab. Please note, I have uploaded a modified, edited syllabus for lab to help you keep on track with how things are going to work. I took away one of the catch-up days at the end of the semester and just moved all the labs down one. So with that in mind, that's our plan for lab. If you have the pre-lab for the freezing point depression lab, you can turn it in, but it doesn't need to be turned in till next week. Be ready to be, assuming the rain we're expecting on Tuesday does not freeze, expect to be back in class on Wednesday and pick up where we left off. So the video I'm going to ask you to watch is regarding integrated rate laws. Integrated rate laws are the inverse of differential rate laws. Differential rate laws looks at a speed of a reaction. That how fast is the curve dropping? How fast does it take for it to level off? How fast does it take for a reaction to build in and plateau? You're looking at the relative speed with respect to concentrations. While the integrated rate law is looking at expected concentrations with relationship to a time passage. That if I were to look at this period of time has gone by and I started with this much product or this much reactant, how much reactant would be left, or how much product would be formed. It's most often used as an inverse way of telling time passage by looking at half-life, looking at carbon-13, carbon dating, because the carbon-13 ratio is set, and we can look at how much is remaining after a period of time. So we have two concentrations, and by looking at how far these concentrations are away from each other, we can figure out how long has passed. So it's a very useful thing of telling time passage. But while it does involve calculus to generate these equations, we will not have to do the calculus as the equations will be given. But if you know some simple calculus, how to do it integral, you could derive a integrated rate law from the differential rate law, but we will not be expected to do that. So, as I said, watch that video. That video will deal with the majority of the math that is abundant in this chapter. Doing integrated rate laws is the easiest and probably the most common type of math we should expect to see. in these type of in this chapter. Now, where we go from there, it's going to be a little bit more complicated math, but it's not going to be as commonly seen. But I'm going to stop for now and leave you to watching that video. I hope to see you on Tuesday/Wednesday.